All right. Let's discuss what we went through during this class. It's going to be pretty simple since you already took it. We want to turn on two motors. For two conveyors. This is motor 1. We have motor 2. Basically, this moves a conveyor belt. This moves on a conveyor belt. Alright. The simple rule will be when one is on, the other one cannot be on. But when one of the two conveyors is on, I can jog the other one. Alright. So for every project that you would do, you're going to do a control panel. Start with control panel. So your control panel is going to look like this. A start button, a stop button, a jog button, motor 1, motor 2, start 2, stop 2, jog 2. So basically this is a push button station. Let's say this measures like about 10 inches, 8 inches. Okay. After the control panel, this is what you're going to do for every project that we're going to talk about. We're going to do the I/O wiring. So let's keep it simple on your I/O wiring. I'm going to use a Do More PLC. These are your inputs, these are your outputs. So basically, this is your, instead of putting I, let me put something you can relate to. X, and these are your Y's. X0, X1, X2, X3, X4, C2. And this is specific to our PLC. It might change for other PLCs. Notice that our PLC has more inputs and more outputs as well. X5. We're going to connect, so notice that we're going to supply our 24 volts from here. So let's start with our push button. Start. Let's wire the start. Start 1 goes to X0. So if I have 24 volts coming in, which is your positive side, on the common side, I'm going to put negative to complete the circuit, right? Then we're going to have the stop button, normally closed. Just remember, there's always going to be a 1 here. Without even pressing it, there's always going to be a 1. Then you're going to have your jog button, normally open. Jog 1, stop 1. Okay. The start 2. This is for your second motor. So notice I got start 1, stop 1, and jog 1. Start 1, stop 1, and jog 1. So whatever I put in my control panel, I have to wire it up. Now we go for the next one. Stop 2 and jog 2. So we're going to connect our C2 to our C1, so they have the same. C2 and C1 have the same potential or voltage level, which is the negative side, 0 volts DC. On our output side, I'm going to apply 24 volts DC. I'm going to go to control relay 1 to turn on motor 1, control relay 2 to turn on motor 2. So notice that I'm supplying the 24 volts here, and when the program turns it on, basically it's going to switch it on to here. So I supply 24 volts here. When the PLC turns on each one of these, let's say this one turns on, 24 volts go to here. But in order to turn on the relay, I need to put the negative side, your negative voltage on the other side. Negative, right? So you're negative, just like a battery. And this is going to be your 0 volts DC. Okay. Now that we have that, let's go into the DualMore program and start programming. DualMore Designer. Let's open it up. So notice that stop 2 is right. Is always is normally closed. I'm sending a 1 here. So going back to DualMore Designer. Okay. See if I open more than one. All right, let's go new offline project. Notice that I have different DualMore PLCs, right? But we're going to use a simulator. So this is my ladder program in my main program. Notice that this rung 1 is located right here, main, rung 1. Rung 2, when we start programming rung 2, it's going to appear here as rung 2. There's other types of tasks and programs and routines that we can call later. We'll talk about those later. Let's open up the DualMore simulator, which is our PLC inside our PC. Okay. Let's hide this window for now. We're going to go online and view this project, because the project that we have is the one that we're going to code. We're not uploading from the PLC itself. So we're going to use this project. If you wanted to see a project inside the PLC, you will go online and view PLC project. Or you can just cancel and return off to offline. I'm going to go online. I'm going to be connected. So it says the current loaded disk project will remain in memory. If the PLC is a different type than the current project, the project will be modified if needed to match the PLC, and any required changes will be directed to the output window. So this is what we're going to do this. This information to initialize the internal clock of the PLC. We don't care about that right now. We're going to hit cancel. So we're going to start writing the code. If you notice, we have not downloaded anything. We're in turn mode in the PLC, but we're communicating. You see this? It's saying that it's receiving information and sending information. The PLC basically is communicating, and it has power. So let's start doing some programming. So based on the class, we're using tools and the document editor. All right. And this is our document editor. It's where we put our inputs and outputs. We can put a lot more. We can put our C values and other registers in memory. For now, we're just going to put the I/O wiring. We're going to add records. X1. Our nickname, start 1. Notice, that I put start 1. Actually, and X1, based on our I/O wiring, is a stop 1, so that didn't match. We need to make it match. Going back, stop 1. You can also delete. If I want to delete this record, you can delete it. Delete it. X0 is start 1. Notice also that it tells you got X0 all the way to X2047, 2047 basically. So you can have 20,047X values in there. That's 20,047 inputs. That's a lot of inputs. So let's start here. Start underscore 0 or start underscore 1. And here in the description you can put a lot more details. So start button for motor 1. Add record. X1 stop underscore 1. Stop button for motor 1. X2 jog button. Jog underscore 1. Jog button for motor 1. A record. X3 start underscore 2. Start button for motor 2. A record. X4 stop button. Stop 2. Stop button for motor 2. A record. Jog 2. Jog button for motor 2. So look, we have already all our inputs and it matches, right? Let's make sure. X0 start 1. X1 stop 1. X2 jog 1. X3 start 2. X4 stop 2. X5 jog 2. Perfect. Now we have all our inputs. What else can we add in the documentation editor to make it more easy? So we got Y0, the outputs, and Y1. So let's add those. add Y0. Same thing. We got 2047 outputs that we can add. Motor 1 on. Record. Motor 2 on. Remember, nickname, you can put whatever you want. And description as well. Extra info, I usually put like wiring number. Usually. We don't have wire numbers right now, but I would put something like that. So now that we have this, let's go back to our main program. Look, I can switch him back and forth from documentation back to main. I can go to my dashboard as well. Even provides YouTube videos. For now, we're going to back to main. So we're going to drag and drop our first part of the program. So we want to start a motor. So the logic behind it is, let's start first the first motor. And while the first motor is on, I cannot turn on the other motor. Motor 1 can be, let's turn on motor 1 with the saying that if motor 1 is on, motor 2 is not able to be on. Or when motor 2 is on, motor 1 cannot be on. So X0 is our start button, right? Notice that I got my normally open contact. Notice that if I had right here X1, I didn't have to drag and drop. I already have my instruction in there. So you can do that as well. If you click on the instruction, let's delete this. I can just write X1, and you already have a normally open contact by default. X1, and we're gonna say, well, let's start. The logic is, what do I need to turn on motor 1? There's various options. I'm gonna start by putting a C1 in, or C0 actually. So you can hit there, or you can actually hit here, or you can hit the magnifying glass and double click on the C0, and you're gonna get a nickname. Motor or MTR1, which is the same, uses that as a short word for motor, underscore motor 1 permissive. Okay. Right detail, select. And you can hit select again, hit OK. All right, so since I need to maintain C0, so notice that on our wiring, when I press the start button and I let it go, I always have a 1 on stop button, right? So basically this is like having a direct path to turn this on, but I need to turn on start 1. When I press it and I let it go, it's going to turn off, right? So I need to maintain it on. So what you're going to do is you're going to click over here on the X0. You're going to hit control, the control button, and use your arrow keys like this. You go down on your arrow key, go to the right, and go back up. So basically, for your understanding, to add branches to your code, you're going to press the control key plus any of the arrows, depending on the direction you want to go into. If you want to, this is adding, right? Adding branches. If you want to delete branches, you're going to hit control plus shift, and then when I say plus, it's and shift, not hit the plus sign. Control plus shift plus the arrow sign. So depending on the direction you want to go. Depending on the direction you want to delete, right? So right now, if I want to delete here, the branch, I could control shift downwards, all right, and then left, and then down, up again. If I want to add, I let go of the shift button, leave control on, and move the arrows. All right, and again, I can do the same thing. I can drag and drop an instruction there, hit C0, or let's delete it again, hit control there to the side, hit the arrow, right, and then just write C0. So the default instruction is always a normally open contact if I just type it in. All right, so I just want to turn on motor 1. Let's say just motor 1. If you think about it, motor 1 is on. But motor 1 is on, right? I'm turning on motor 1. Let's do motor 2. So what are my inputs? Let's go over here, back to your drawing board. Or you can just see the IO wiring, or you go to the documentation editor. So that's good. That's why you should never press the X, so you can go back and forth. Documentation editor, motor 2 is X3 for the start. So X3, X4. Notice that it's normally open because I'm always going to have a 1 here. So I have a 1 already here. So it's going to let past the flow, right, of the logic. The switch is on right now. Even though it's normally open, since on the wiring it's normally closed, it's already passing through. Over here is now, I have to press it to make it on. So I have start, stop, C1. Let's add a value to C1. Actually, I gave C1 to that one, right? So let's use C2. You can use any range of values, right? So in this case, C0 was motor permissive, motor 1 permissive. Let's use C1. I like C1. Motor 2 underscore permissive. Okay. You can also go over here on documentation editor and notice that we could have added C1, 0 and C1. But you probably won't know that until you start programming. So going back to the do more, your main program. Now when C1 is on, motor 2 is on. Okay. Now notice that there's no condition that prevents me from turning on motor 1 if motor 2 is on. Okay. So what I can do, in fact, I'll prove it, right? Let's prove it first. Let's write to PLC. In fact, let's save our project first. It'd be a good idea to save it. You hit yes. I don't know, you probably saved it already. My first PLC program. Hit save. Can write description, version, your company name, department programmer. Okay. Now let's write to the PLC. Right. We can put switch to run mode after download. We're not going to do that right now, but we are going to download the project that's here into our virtual PLC. Hit OK. Yes, all status on means that we're going to start seeing green lights if they are on, right? So yes. Since our PLC currently is probably, so we go to run mode. Okay. So if we go here, so notice that our push buttons that we have on the training station, when we press them, they come back up, right? So in this case, if we press this and stays on, we have to, in order to simulate, we have to simulate the button that we have in real life. So we have to press it and let it go, right? Just like X1. X1 right now is appearing as normally open. So over here, I just said that it's normally closed. You always have a 1. So what we're going to do is, on the wiring, we have to simulate a 1. Now we have a 1. We're simulating a 1. When I press X0, I have to let it go back again, just like in real life. But notice that permissive is on, motor 1 will be turning on. So Y0 is on, right? Now let's check if I can turn on motor 2. Let's prove it. So to turn on motor 2, I have to simulate X4 as normally closed. So I have to leave that always on. X3, I'm going to press the start. And when I let go my finger off the button, it's going to come back up, right? What am I missing that didn't stay on? So what I'm missing is this little branch that leaves it go on, right? So we're going back to the edit mode, and we're going to add that. Let's disconnect from the PLC. Right now I'm disconnected from the simulator, and we're going to add that little branch there. C1. Okay. We're going to connect again to the PLC, to my simulator. I'm going to select. This you can hit cancel. Okay. Let's save our project. After we save it, we automatically have the write to PLC. So just follow this process, you'll be fine. Let's write to the PLC the edits that we made. Hit OK. Let's see all the status on. And notice that now we'll be able to see something real nice. So now we have X4 always on. When I press X3, turns on, and then when I let go of the button, it stays on because of the branch. This little branch here. So now, notice that I have motor 1 on, motor 2 on, and motor 1 on. But we said that we have to make the code so that when one motor is on, the other one cannot be on. So there's several ways you can accomplish this. I'm going to give you some hints. So let's go back to edit mode. Okay. You can disconnect to the PLC. Okay. So when motor 2 is on, what tells me motor 2 is on? Well, you can use several bits. You can use C1 or Y1. Let's use C1. So you can go over here and say, well, go to edit mode, drag and drop a normally closed. So when C1 is not on, right, then this is true. So basically when start button is true, when stop is on, which is always on, and motor 2 is not on, then this can happen. This is saying this is an on, so it's this and this and this have to be true in order for this to be true. It's called an AND. And the same thing we can say over here. Y3, drag and drop. C0 cannot be on. Okay. So we want disconnected, it seems. Okay. We're connecting back to the PLC. We are saving. Oh, yeah. Cancel. We're gonna save. Accept all wrongs, yes. And then we're gonna write to the PLC. Then click on all status to see the status of everything. Notice now that motor 1 is not on. Can I turn on motor 1? Let's find out. So motor 2 is on. Yeah. Y1 is on. Look at it. Y1. We go to the RL wiring. Y1 is on. Let's try to turn on Y0. Okay. Let's try to turn on Y0. What do I need to turn on Y0? Press the start button. So I press the start button, let it go. It never turns on. Now, what happens when I hit the stop button? So notice that I have a 1 on the stop button, always, right? I always have a path here, right? Until I press it, the stop button, I break that path. So the stop button works this way, right? I have a connection, normally closed, right? When I press the button downwards, the button disconnects the switch. So now I need to press the button, right? So on the simulator, X4 is my stop button too. So when I press it, let go, it turns on again, but motor 2 turned off, right? Because I cut the path, this one turned off. If this one turns off, this one turns off, it no longer is on. Okay. Now I can turn on motor 1. I press X0, turn it on, let it go again, and it's always on. You saw how this maintains it on? Look, I'm going to press the start button, the stop button. I press it, let it go, it turns on again. Okay. Now let's press the start button again. I press the button, it turned C01, right? I let go of the button, and this continues to turn on until I hit the stop button. Okay. So let's leave it on for now. Let's try to turn on motor 2. Motor 2, I gotta hit X3. X3. It's not letting me because this is not permitting the path to C1 to be true. So if C0 is not on, this is true. Right? Look what happens when I press the stop button. You saw? Now this permits the path to C1. So now I can turn on motor 2. Okay? Now, let's go back and let's do the jog function. We disconnect. Okay, hit the edit button. Also notice, again, on the main program, now we have run 1, run 2, run 3, and run 4. Run 1, run 2, run 3, and run 4. Let's go to run 1 or run 2. So it can be on whenever the permissive to start is on, or if I jog the motor. Jog X2. Okay. Now I'm going to connect to the local simulator. Select. I'm connected. Okay. I'm going to hit save. Yes, I want to accept that. Okay. And we're going to write to the, well, actually, let's add the other one as well here. X5. Let's see here, X5. We added that new wrong. I'm going to write to PLC. Wrongs have been changed because we changed them before we connected again. So yes, I want to save the changes and download. So now there's more than one condition that can turn on motor 1. It can be turned on by this part or can turn on by the here. Okay. In the simulation, or notice that the jog button for motor 1 is X2. If I press X2, it's turning on even though Y1 is on. So play around with this simulation. Try to understand it as much as you can. Notice that put it side by side, and you can play around with it all you can. Okay, it's not good. X2. You're not seeing it. You know why you're not seeing it, the status change? Because you gotta hit all status on. There you go. So notice that this is not on, the permissive is not on, but the jog bypasses the permissive and turns it on. Okay? The same way the jog bypasses the permissive and can turn it on as well if the permissive wasn't on. So I hope this video clarifies everything as much as you can. Watch it more than once. Write your doubts down, okay, and save your project.